to my channel. This is Mihran from Mihran's Orbit, and like last time we talked about this series, uh, we had cosmic rays. I believe it has been like 2 days, so I believe, yeah. These cosmic rays, as we talked about back then, were very really like radiation coming from outer space from different things like neutron stars and etc. And we told you what the next time we the next topic we did was. It was gamma radiation. So gamma radiation is like, it's a very simple topic after you understand it. Now we are getting from space all the way to earth, and tomorrow will be another radiation thing. But uh so so the like the main beneficial thing that is gamma radiation, it's just like black hole radiation, or it's neutron star radiation. It's the same as cosmic rays. We don't need to go too in depth with it, because you probably know what gamma radiation is. If you don't, well, this is what it is. It's simple. It's just that this super strong radiation which could evaporate, like just two rays of these gamma radiations coming down to our earth, can cause it to like absolutely melt. Now this is gonna be a little hard for me because I'm trying to go from space to earth, and then like that's gonna be hard because alpha and beta radiation, just a quick measure, that's the next time we're gonna do this topic. But alpha and beta radiation is essentially the main things that we talk about of radiation. Gamma radiation is so far away from earth we don't even talk about it, but it's so powerful. Like, one of these rays can almost destroy all of humanity. Just imagine. Not because of electricity, it's just because the energy it produces allows like even more than floods power. Like, that much is so like hard for us. We don't find food, we don't find water, we won't be able to do anything because everything is radioactive. Well, like now this is not the exact thing, because there are weaker versions of gamma radiations that are like stronger versions of beta radiation. And you'll understand why I'm saying beta, alpha, and all of those things. It's pretty self-explanatory after you understand what it is. uh, so the thing is about this gamma radiation, it only comes off of two different sources: neutron stars and black holes. These are the two different sources that we can actually get gamma radiation from. Because like, even though gamma radiation is produced by stars, I believe stars don't create enough energy. It's considered as like really 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 medium type of thing. Medium beta radiation is considered like that. That's the strongest we can go. Like a really really big condensed star, I guess, would be able to create gamma radiation. Like a really really big powerful star which can create a lot of radiation, like even like more than 3 4 5, like that much level of radiation. So tiny because it can reach them more, would be able to do it. Well, there is already a type of star like that. It's a neutron star. Neutron stars will be probably one of our videos next a few in a few days, because like they're so interesting. They have strange matter in them. Well, another kind of matter. Welcome to the sixth matter in a series that doesn't even talk about matter. so, so, so the that's about it. Like, that's about it. We can talk about gamma radiation. Other than that, you are safe from gamma radiation. Don't worry. Don't lock yourself in a chamber right now. You're safe from gamma radiation because even Earth cannot be reached by anything. Like, the closest source is like 200,000 light years away. That's so much. You don't need to worry. You don't need to worry. You'll be fine. Everything will be right. Like, so, like things. But sometimes there are like really strong gamma radiation that actually comes to our surface as a really strong cosmic rays. Sometimes these create even power outages in different types of countries. Well, so that's about it of like gamma radiation. And there are not too many facts about gamma radiation. So we'll recap a bit, like to what else is gamma radiation. So black holes last. We have been talking for black holes for the entire series because like black holes are so important for radiation, at least in the subject of radiation. Uh, now, now the problem is that we cannot really identify what kinds of things. So like, what do we actually do? Let's talk about the facts at least we can know mostly. Gamma radiation. So gamma radiation is definitely powerfuler than sulfuric acid, but I think gamma radiation is a little bit too powerful. Sulfuric acid is so strong. It's too strong, essentially. To so like a rock will be melted almost instantly by sulfuric acid. It'll be it'll be not even a flash. Even if you blink, you'll just go away, and gamma radiation will do that. Of course, this is though the stronger types of gamma radiation. It was like if you put neutron stars like relatively close, and by that I mean like 1 light year away. Yeah, that seems like fair. Light will go around for 1 light year. It makes sense. Yeah, I mean, like that's like it. Now, gamma radiation is very strong radiation. By that I mean strong radiation is really not it. So like the thing about the all of radiation that at least comes in clusters like cosmic rays and also all of those things come with different types of radiations other than like the already radiation. And I kind of did lie because cosmic rays aren't really radiation. They're essentially a type of radiation though. The neutrons and everything can affect so much of our daily lives that it could be classified as radiation. So it is essentially just radiation, right? So, but what are the ways that actually work with, and like what are the gamma radiation things? Now, gamma radiation, like said, is actually gamma. It's actually gamma. So for those of you are wondering, it is actually gamma. But so but though the but the gamma radiation is actually radiation. It's just radiation with muons, neutrons, and all of those things that were actually in the cosmic rays. That is a strong thing that like is power like so strong, like it's so strong, right? So that's the thing about gamma radiation. But there's more I think we can cover. Well, last time I think I can cover more. uh, so gamma radiation is actually a lot unknown because, and it's also a little different than other radiations, because if it is necessarily just matter, I should also probably explain all the later things. So the definitions of things a little bit later. Now it's just it's so hot radiation. It's just hot radiation, which is not a term I know. There's no radiation that is very hot. Don't look it up in Google. Listen to me. The thing about this is black holes. You know them? They're kind of hot because have you ever seen the glowing outside? Doesn't that seem very hot? It's not really very hot. I mean, yeah, but it's still hot. So I didn't say it's very hot. Okay, there's neutron stars which are like burning hot, and like like they're not really burning hot, but I guess they're very like hot necessarily outside. So that is why gamma radiation is kind of hard, but there's really not a term. Again, gamma radiation is never just some kind of just particles. The radiation itself is just these things that are coming off. These are so small molecules that they don't even like are so in small scales. Radiation is coming from everything. Like this wire, it will eventually radiate a little bit, which which is because some of these atoms are coming together in clusters and will eventually, meaning a few million years later, form a, a single atom of like a radi- like a radiation element, and then it'll become more, and then it'll start doing like this and this and start radiating, right? So it'll radiate like this, and well, that's about it. Yeah, I think that's about it.